Okay, let's see what we remember, what we don't remember about simplifying. The first one, where we have the base of 4 for both, but we're asked to multiply those two. What's the rule we're going to do there? What do we do if we have like bases and we're multiplying? What do we do with those exponents? Half and good. So in this case, 4 squared times 4 to the 5th would give me 4 to the 7th power. Now you can type that in and see what you get for that actual answer, but 4 to the 7th would be okay. So that would be using this rule. If I have x to the a power times x to the b power, we're going to add a and b together. All right, what about part B? Well, part B, we have 5 to the 0 power, and then it's to the 3rd power from there. So we actually had a couple options. If somebody tell me what they did in that one, what'd you do, Jeff? I'm sorry?
I just put 1.
Yeah, that's right. How come?
Because anything to the power of 0 is 1.
Okay, and then once we have 1 inside the parentheses, to the 3rd power really didn't matter because it stays 1, right? All right, so that's one way we could attack it. What's the rule we have in general? Now this one, it wouldn't have changed things, but in general, when I have a power to a power, what do I do with those exponents? Multiply those together. So another way you might have thought about it is 5 to the 0 power cubed really becomes 5 to the 0 times 3, or 0, which still results in getting 1. So that's another rule we have to think about is anytime I have power to a power, I multiply those exponents. Now it didn't pop up here, but what's our rule for division? There's not much space there. But if I had two things I'm dividing, what do I do with exponents there?
You subtract the top one from the bottom.
Right, so we're going to subtract the two exponents. Okay, so those are kind of our three basic rules. Multiplication rule popped up again on this next one. So again, we're going to add those exponents. But now we have to worry about this part, the one where we said we don't want any negative exponents. So how are we going to deal with negative exponents? Well, we'll kind of get more in depth on negative exponents later. But let's just think about negative exponents in general. If I had 2 squared, I have 2 to the 1st. We just said the 0 power gives me 1. If that pattern continues, what am I doing to these values as I went along? How do I get from 4 to 2 and 2 to 1? Divide by 2, multiply by half, if we're thinking it that way. So if I divide this by 2, I'm now looking at a half. If I take half of a half, which would be the next part, I now have 1/4. So if I looked at positive 2, it was 4, versus an exponent of negative 2 is 1/4. So when I'm looking at the negative exponent, what I'm really doing is the reciprocal of our positive exponent. So if I have x to the negative 2 power, if I want to make that positive, what's it going to be?
1 over x.
1 over x squared. Or the way I usually like to think about it is, if it's negative in the numerator, I'm going to move it down to the denominator, and now it's positive. If it's negative in the denominator, I'm going to move it up to the numerator. Now it's positive. All right, this last one kind of had a combination of rules. Power to a power popped up again. So I got x to the negative 1 times 3. X to the negative 3rd. I've got y squared to the 3rd power, so that's now going to be y to the 6th. But I had my negative exponent situation that showed up. So how am I going to rewrite this one where I don't have any negative exponents? I'm close to having it simplified, but I'm not quite there yet. Ideas?
You take the x cubed and put it on the bottom, so
Right.
you get y to the 6th.
Good. Now y to the 6th was already positive, so we don't deal with it, but that x to negative 3rd we move down to the number. So today we're going to do some practice with our exponent rules and looking at making sure we can simplify those things. Before we do that, though, I want to go through a couple of the problems that were on your homework that you're supposed to have done for today. The first one was number 35. I'm going to look at part B from 35. Somebody had some trouble the other day when we did a problem similar to this, so I want to make sure that I followed what was going on. On number 35, they wanted us to write it as an exponential, so they said it's going to fit this form, y equals a times b to the x. And remember, in that form, the two main things I need to know would be this value, which is our pattern, what we're going to multiply by each time, and this value, which is going to be our zero term, or the initial term. So this is when x would be equal to 0, our initial term. This is going to be what they sometimes call the multiplier, or pattern that we're going to have. Well, the first thing I got to figure out is what was the pattern. So they gave me two values, and luckily they were right next to each other. So I can take those two and divide them. So if I take 72.312.77.312 divided by 6, I get 0.8. So I've got a pattern here of multiplying by 0.8. Now, if they hadn't told me it was exponential, I wouldn't be guaranteed just by 2 points necessarily that it was going to continue that pattern. But they told me that it was. So I've got my b value. So I'm halfway there. Now I got to figure out a way to get that 0 value. So this is a case where, again, we're going to backtrack. Instead of multiplying by 0.8, I'm going to have to backtrack. And now I'm going to have to divide by 0.8 2 times. So I'm going to go ahead and do that division and see where I started. And I get back to 150. So part B, that would have been that equation that you should come up with. Another one that hopefully we're starting to get a little more comfortable with was 37. And 37 was talking about Dusty, who won $125,000 on a game show. He decided he was going to invest that, and he was going to get 6.25% interest. And it was going to be compounded annually. And he's not going to pull any of that money out until he retires. So they wanted a couple things. First of all, they wanted an expression that would show how much money he had after T years. So if he's going to start with 125,000, that would be our 0 term. How would I write getting 6.25% interest? What would be my multiplier on this one? This is like getting that 6.25% extra credit. Ellen?
1.165.
Good. What do you think the most common error I usually see with that there, if you're doing 6.25%?
Maybe not adding the 1 and just adding the 2.
Yeah, that's one of them, is just putting 0.0625. If I did that, would that make my money get bigger or smaller? Actually get smaller, right? The other common error I see is forgetting about the 0, 0.625. So make sure that you convert that correctly. Well, now that we have that, figuring out part B is just a matter of plugging in 23 per x. Yeah, I don't remember what it was. We're going to end up with about $34,032. So it'd be a good investment. But being able to take a situation, come up with the expression, and then use that expression is something that we'll get more comfortable with. Then the last one I want to talk about was number 47, specifically part A. Part A and B both gave you situations, and they asked you to try to come up with 1 or 2 equations that would help you solve it. So part A was talking about the Lees, and they had 3 children. And they said that the oldest is twice as old as the youngest. They said the middle child is 5 years older than the youngest. And we know that sum of the ages is 57. So essentially we got the young, middle, and the oldest. And we know all of them, when I put them together, are going to be 57. Now, both of the references came back to the youngest, so that's what I'm going to make my variable. So I'm going to make my x be the youngest. And if they ever say something about a let statement, that's what they're saying. It's basically define the variable let x equals the youngest. So if x is my youngest, let's figure out the middle. Well, I said the middle was 5 years older than the youngest. So I'm going to have x plus 5. They said the oldest was twice as old as the youngest. So that's going to be 2x. And they wanted the sum of those. I'm going to add all those. So that might be a possible equation that we have in order to solve this. Then from there, you just go through it and figure out your value for x. So I just want to make sure you have this set up on that one. Make sure, if you haven't already, that you submit those. And I'll look through them and see if there's other ones that we need to talk about as well. Like I said, to start out with today, what I'm going to have you work on are a number of problems related to simplifying with exponents. The title of this says negative exponents, but not all of them have negatives. As you're working through these, again, think about the 3 things we want for a simplified expression. We want to get rid of parentheses. We want to combine any like terms that we can. And we want to make sure we don't have any negative exponents.